Hello everyone, welcome to this video, and in this video we will be learning all about vectors. So vectors are one of the most important and the most used data structures in C++ and DSA. It's used in graphs, it's used in dynamic programming. We'll learn all about it. So let's get started. On the screen, you'll see that on my right is my writing pad where I will be teaching you concepts. And on the left, these are all the things where we will code. So thinking about vectors, you can think of it as like a dynamic list. So what I mean by this is that, for example, let's say you are the headmaster of the school and you want to collect all of the students in one line. So students are the elements of these line, and there is like some property of each student, right? So what you can think of it is like it's kind of a line. The first student, the second student, the third, fourth, and fifth. And naturally, we see all of these kind of data structures and the need for these data structures a lot in computer science. For example, if you want to collect all the set of emails that have logged in to your website, you can store it in a vector. And this is just a very simple example of it. So you can think of vectors as dynamic arrays. And what do I mean by dynamic, right? By dynamic, I mean that like you can increase and decrease the size of this vector on the fly, and you can do it very efficiently. I'll like explain in a bit what exactly and how much time does it take to expand an array. Okay. But for now, you can think of it as a list of similar elements. So let's go ahead on the left and try to initialize a vector. So wherever, like for example, you have been told to take input as a list of heights of student, I need to find what is the average height of all the students in your class. Okay. So you can easily solve this using a vector. Okay. So we will see this using the examples. So let's get to the coding part. So on the left here, if you see, you can ignore the input and the output for now. I'll zoom in a bit. So first, how will you initialize a vector? First of all, you have to include the vector library for the C++, and you can do it just by writing #include vector. And like you will do this a lot of times. What this line does is it will include all the necessary libraries that you will require for coding. So let's get started. Initialize a vector, right? So this is how you do it. You first write vector, then open these braces, and then you want to say what kind of elements do you want to store in the vector. So let's say I want to store integers. So I will write int. Int is short for integer. So this is telling my computer that you have to make a vector of int, and then you have to name your vector. So let's try to name it, let's say vector 1, okay? Vector 1. So what we have done here is now we have initialized a vector named vector1, and it contains elements of type int. So generally the format will be something like this. You have to write vector, basically the type of the elements that will be included in the vector, and then you have to write the name. Okay. So this is how typically you will tell your computer, okay, go ahead and initialize a vector of name vector1. Now, what if you want to initialize a vector of, let's say, of size 5. So let's say you know beforehand that you have 5 students in your class and you want to initialize a vector of size 5. This is how you can do it. So vector, then you say that, yes, this vector will contain elements of type integer, and you name the vector, let's say, vector 2, and then you open parentheses, and the first argument will be what is the length of the vector that you want to initialize. So as I told, let's, for example, take it 5. And after that, you can tell the vector that what is the default value of all the 5 elements that you want to initialize. So let's say we call it 10. This is initializing a vector of size 5 and all the elements are 10. So in the memory of your computer, there is a vector 2 and there are 5 elements. Every element is 10. So this is like very helpful in cases where you want to initialize a vector of size, let's say given x, and you want to initialize every element to 0. So this is very simple, right? So you don't have to go ahead and iterate and then set every element to 0. This is a very powerful technique, and please remember this. And it is very important for you guys to actually go ahead and write this code, because in your brain you will think that, okay, I understand this, but you have to write it like 10 times, 20 times, then it will be ingrained in your memory. That's how important writing code is. So please, please, please write the code. Now let's say we want to calculate the size. What we can do here is that, let's say we say that we are calculating the size and storing it in this integer called size vector. So how you can do it is that you can just simply say vector2 dot size. So what this will go ahead, you can go ahead and print the size and it will be printed as 5. So if you just try to print this, right, you see this. This is the output of the program that we've executed. And why it is printing 5? It's printing 5 because we initialize the vector size here to be 5. And we are going ahead and printing the size of the vector. So the syntax for this that you have to remember is write the name of the vector. So you write the name of the vector, do a dot, and then you invoke size. This is how you can get the length of the vector. Now, let's say we want to print each element, or let's say you want to access each element of the vector. How you can do that, right? You can just take a for loop and iterate over like the size of the vector and write a simple for loop. So I am assuming that you guys know how to write a simple for loop. So we already know that this vector2 is in the memory of our computer, right? Somewhere it's stored. Now, if you want to access elements, all the elements of the vector are 0 indexed. So what do you mean by is that the roll number of all of these elements start with 0 and not 1. So when you say roll number 0, the first element will be called out. Roll number 1, the second element will be called out. So this is how computers are different from the real world. Everything starts here from 0. Since we initialized a vector of all elements equal to 10, let's say I say that show me what is the element number 2. You can go ahead and just write this. So vector 2 and 2. So this will give me the third element. This is how you go ahead and access the third element. If you want to access the fourth element, you will write vector 2, 3. And one thing very important here to note is that you cannot access elements which are greater than the size of the vector. Then it will throw an error for you. We can go ahead and try to access the elements here. So let's say we write vector 2 and we are accessing the ith element, right? So we are just going ahead and printing the elements of the vector. So first the size will be printed and then the elements of the vector are getting printed. You see here, right? 5 is the size and the elements are 5 tenths. So you can go ahead and simply do this. Now, printing all the elements of the vector. So this is what I showed you on the top. So we don't need to cover this. This is already done. Now let's talk about like the dynamic part of it, right? So when I told you that vector is a dynamic array, what is the benefit of using a vector? So let's say a new student joins your class and you want to store the height of that student. Okay. So obviously you can do one thing is that you can again make a new vector of size 6 and insert the height of that particular student. But a very flexible thing that you can do is that you can simply push back the new student here. What you can simply do is that this is the vector 2, which is already there in the memory. At the 5th index, you push the height of the new student that is coming in. Let's assume the student is the tallest. Let's assume the height is 15. you can just simply write vector2 dot push back. So this is pretty simple to remember, right? You are pushing back an element at the back of the vector. This is what you need to remember. And on the brackets, you have to mention what element are you pushing. So let's say we want to go ahead and implement this. So you can just simply write vector2 dot pushback 15. So this is how you can introduce a new student, a new element in the vector. And let's try to print the vector again, right? Then you guys be able to see. So we are printing the vectors 2 times, okay? So first is, just see here, why was the last element not printed here? Because the size vector has the initial size, which is 5 of the array, and we are only printing till 5. So you have to be careful about this thing. What you have to do instead here is that you can write iterate till the entire vector2 size and not just 5. And now you will see 15 as well. So your new student has entered the class here, right? So pretty simple. Now, one thing a lot of people don't know about is what is the time complexity that this operation takes. So a lot of people think that this operation is order of 1. What do you mean by order of 1, right? So like if you're not really sure about this, I will be making a video on time and space complexity. So please go ahead and watch that. But assuming that you know what time complexity is, this pushback operation is on average order of 1. So what happens in the memory is that, let's say you initialize a vector 2. So this is not what exactly happens, but this is how the concept works. What the computer will do is that it will decide a starting location for this vector 2, and then it will also allocate like a continuous cell in the memory. So let's say this vector 2 is starting at this address. Let's call this address 1. Okay. Let's say, I mean, it can be a random address. It can be Mumbai. Let's say it starts at Mumbai. So what the computer is doing, it will remember Mumbai, and the computer knows that it has reserved 5 places for all the elements that are going to come starting at Mumbai, right? So initially, let's say the number of places reserved is only 5, and you can like simply keep pushing back the characters until you reach a size of 5. Let's say you want to insert more elements, right? So what internally this vector does is that now it will erase this location. It will go ahead and find a new place, let's say Delhi, and in Delhi, it will reserve a place of 10 boxes. It will keep doubling the entire capacity that is had. So sometimes what it will do, it will go ahead and copy all of these numbers to a new location. Okay. So this is why it is not exactly order of 1. Sometimes it also has some spikes in the middle, like during the execution time. But all in all, if you take like on average, this will happen very few times, and people consider that it is order 1 on average. Okay. So these are the concepts that you should know. You should think that how is this thing getting implemented in the backend? This is what will show that yes, you are like you know the concepts really well. Now let's talk about popping back from a vector. You can just, so what I mean by this is that let's say like the 6th student is not doing well in the class and you want to kick him out of the class, assuming the student is a guy. You just need to go ahead and expel the student. You can simply do it using this line of code, which is vector2 dot pop back. This is something like you push back and then pop back, right? Now, one more thing you need to remember is how to sort a vectors. Let's say what we write is that sort and then vector2 from where we need to start sorting, the beginning of the array to the end of the array. What this will do, it will go ahead and sort the entire vector. Let's try to print again. since we popped back the last student, and since all the numbers are 10, you're not really able to see what's happening here, right? So let's do one more thing. We will push a short student, and let's assume the height of that student is 7. Okay. Now let's go ahead and try to see the results. So the 7th student came with a height of 7, right? And then the 7th student was removed. And okay, so what we can do here is that, let's say both of these students had height 7, and one of that student got popped back, and when you sort, the last student came at the first. So this is how the sorting takes place, right? Now let's talk about the next thing, accessing the last element and the first element. So how you can do this is, you just have to just remember this. It's pretty simple and very useful. So when you just write this vector 2 dot back, it will go ahead and print the last element. And when you write it's vector 2 dot front, it will go ahead and print the front element. Yep. You can go ahead and try to implement this. So you can see that the last element is 10 and the first element is 7, as we are seeing here. Now, a very important topic, how to introduce and initialize 2D vectors. So you have to think from this perspective. When you initialize a vector, you basically write vector, and then what are the element types in that particular vector, and then you name your vector. Okay. And after that, in the parentheses, you will write the size and what is the default value. So this is the syntax that you have to follow. Vector, then you write type, name of the vector, and then in the parentheses, what is the size, and then what is the default value. Okay. Now let's try to initialize a vector of size, let's say 3 cross 4. Okay, so there are 3 rows and 4 columns. Okay, this is the first element of that vector, this is the second element of that vector, this is the third element of that particular vector. Okay, and each element is a vector of length 4. So do you see this? This is what STL makes the implementation so easy. So what you are basically saying is that you are initializing a vector of vectors. And this is how you can implement a 2D grid. And this is a very common concept in graphs and DP. So what we will do here is that we will go ahead and initialize a 2D grid. So first we write vector. Then what are the elements of this vector like? Each element is also a vector. So each element of this outer vector, the 2D vector, is a vector itself. That's why instead of int, we write vector int here. And then we will name the vector as, let's say, vec2d. And then what is the initial size? How many vectors will be there? 3 vectors, right? And now we have to write the default value of these 3 vectors. We know that the size of each individual vector will be 4. So we go ahead and write it as like, so I have to initialize a vector of ints, and each vector will be size 4. And let's say we initialize each of these individual vectors with the element 0. So this is like pretty awesome, right? In one line, you implemented a grid of size 3 cross 4, and each of these cells have an element 0. So you have to master this. If you know and if you're very comfortable with this implementation, you will be able to solve questions very fast and very efficiently. Okay. A lot of times we also need to deal with 3D vectors. So how can you think of 3D vectors? So imagine that you have a crate of eggs. So one crate of egg is one 2D vector. So generally what you have is that, like, there are, let's say there are 3 rows and let's say 4 columns. So there are total 12 eggs. Okay. And let's say you stack one more crate of egg above or below this. This height, what you call is 2. So there are 2 crates of eggs. Okay. And each crate has 3 into 4, which is 12 number of eggs. So a lot of times you also have to implement this kind of a structure. So generally you can think of the 3D array as a cube. So there will be a lot of like 2D arrays. You can see if you cut slices, right? So the number of slices, each slice is a 2D array that we implemented here, the 2D vector that we have, right? Now what we just need to do is stack all of these 2D vectors like on top of each other. And this is how a 3D vector will look like. So let's say we want to make a 3D vector of size 2 into 3 into 4. How can you do this? First of all, we start with the vector. Now in this outer vector, which is the 3D vector, each of this element is a 2D vector, and let's name this vector as 3D. Okay. What is the size? So first is 2, right? 2 comma. Now, what is the default value of these 2D vectors? That's what we need to mention now. So it's a vector of vector int, and each of these 2D vectors will have 3 1D vectors. 3 1D vectors. And each of these 3 1D vectors have size 4. And all of these are x, so let's call them 0. Yes, so you just implemented a 3D grid using one line. So that's the power of STL, and that is what you need to go ahead and practice. Now, my only request is to please write this code on your own, and that will give you the real mastery that you need to do. Thank you, and see you in the next video. Keep smiling and be happy.